we're going to do this week, both days, is DNS. Today's is an introduction to DNS, with DNS overview. The words, domain name, services, domain name service. We all have an idea of what it does. Takes the names that we like to use and translates them to an IP address. You can also go in the other direction. DNS, you've heard me say before, is a really big deal in Active Directory. And for those of you who have tried to join the domain with the DNS set wrong, you kind of got a hint of that when it said can't find a domain controller. If you're really running a large Active Directory environment, knowing how DNS works and what's sending the requests where is a really big deal. I'm talking about even the ECPI domain, ecpivab.edu. There are a number of different sites, and each of those sites use their own DNS servers to do lookups. So that means that if you are trying to resolve something at a remote location, how do you get there? How do you find out what that one does? You've got to send the request to the correct DNS server. So this is the introduction in Windows 2008. There is one thing that has changed. It looks a little different than 2003. The rest of it configures the same, and that's conditional forwarders. They have a folder now that is much more obvious where to configure conditional forwarders. It's hidden a little bit in Server 2003 in the forwarders tab, but the conditional forwarders become a relatively big deal when we get into this, when we get into it, actually into the Active Directory portion of it. So the objectives: discuss the basics of the DNS and its terminology. Domain name system, domain name service. You'll hear it called both, I think. Configure DNS clients. What do you really have to do to configure a DNS client? If it's a Windows client, what do you have to do? Turn it on. Because by default, Windows clients automatically get the information from DHCP, and DHCP we're hoping is going to be configured here. The DNS configuration that you're going to do is going to be both on your core machines and on this one where you're going to look it up. Going to have some forwarders. The ones that they like to use are a couple of open DNS servers, which are kind of easy to remember. 4.4. I think it's 4.4.4.1 and 4.4.4.2. Anyhow, they're in there. They'll have you configure those things. Install a standard DNS server on the Windows Server 2008. And as you progress through this chapter, what they're going to do is have you set up DNS to fail, then make it succeed, then install DNS and use your own DNS after you get there. And installing the DNS server is one of the last things that you do. And then you're going to create a couple of zones, do some stuff. The next chapter that you get to, you'll have to reset everything. For your full installs and before you start them, what you can do, and I've got the instructions all up to the labs, one of them, they want one of the NICs, two NICs, and you should be able to put the second NIC on. If you can't, we can do that here. One of them is going to be on the public, the 10.60 network, and the other one will be on a private network, and then your core machines will be on the private network, the 192.168.2 address. That way, for the labs that you need to get to the internet, you can get to the internet no problem. You don't have to go through any of the routing information. It just seems a little bit easier to do it that way. Create a standard DNS zones. This is, like everything else Windows, is really tough. Right-click and create the zone. You need to create the zone with the name that's going to be used. Later on, they're going to have you do a secondary zone. Warning, what I see a lot of times when people do secondary zone is they want to name it something that they like. Well, the secondary zone is simply a copy. You got to name it, use the name of the existing zone, the one that you transferred in. So the primary function to translate human readable host names, www.ecpi.edu, into IP addresses, so that you can find an individual computer. All these wwws and whatever else is represent something. When you go to virtualpc.skyline.edu, which used to be ROA virtualpc.ecpi.tech or ecpi.tech.net or whatever it was before, that actually represents a resource whose local name, by the way, is RKE-Midway2. So we can tell DNS to go something based on a name that we want to use. It doesn't necessarily have to be the host name of the machine itself. Flow of email provides mail exchanger records that tell the SMTP server where to send an email message. MX records, mail exchanger records, find the mail servers. Actually, they find the domains. And then you find an A record to actually send it to the email server. Email requires two records, an MX record and an A record. An A record being the one that has the IP address name relationship. Support on the internet by thousands of distributed servers and DNS servers. What did we do before there was DNS? Because it's not been around forever. You're going to have to configure one when you get in here. When there were 5 computers in the world, and at a time, there was a time when there were 5 computers in the world, we used this thing called a host file, where you would actually, in a text file, enter the IP address and the name. That's still there. C:\Windows System 32 drivers etc. folder. There's a file in there called hosts, which has no extension. So when you modify it, please don't give it an extension. That allows you to configure a IP name combination. That is, they always say that's read first. What actually happens is that gets loaded into the cache, into the DNS cache on your machine, so that it is there. If you want to be able to, for instance, just be able to type Moodle at home, modify your host file with the IP address for Moodle. You can do that for a number of different things. You should be able to do that for virtual PC, or, the virtual PC also if you have a name you want to use. The IP address, you got to find the IP address, ping the fully qualified domain name, and then put your shortcut in there. That should be the thing that is read first. If it doesn't work, ipconfig flush DNS may have to be used. One of the things that does happen with DNS is if you get a bad lookup when you're fooling around with these things and it comes back and it can't find it, and you fix it and you do it again, it's going to come back and say it can't find it, because just like it caches the lookups that you do, www.yahoo.com gets cached with the name and the IP address. It also gets cached with the name and the can't find it. And then if you go back, those caches time out. But if you go back relatively quickly, it says, can't fool me. I already told you once I couldn't find it, so I'm not going to look again. You may have to flush the DNS cache, ipconfig/flush DNS. Don't be afraid to use that, particularly when you're doing labs, Active Directory labs in particular. This thing, resetting the network adapters and disabling DHCP, they've got all the command line commands that you need to do that. It's good practice. Go ahead and do that with the command line. It really doesn't take that long. I don't know that it really takes 20 minutes to do that. Depends on how many typing errors you get, I guess. With me, I got a number of them, and it still didn't take me 20 minutes. DNS terminology or DNS namespace, DNS domain, and these are the highlights, and they're going to have a slide for each of these. Fully qualified domain name, hosts, host name, DNS record, and DNS zones are all part of the structure itself. The DNS namespace organized into the following domains: root domain, top-level domain, second-level domain. The root itself, and the root is always represented by a dot. The first time that Buddy Chu and I, put in Active Directory in Windows 2000, it installs DNS for you, and it asked us if we wanted to be a root server. Of course we wanted to be a root server because it was Active Directory. We wanted to be the Active Directory root. Well, it fixed it up for us. It put the root server into DNS. If you make your DNS server a root server, know what you can resolve on the internet? Come on, guess. The root. You can't resolve anything. You're the root. There is nothing above the root. You could only then, and you can't forward because there's no forwarders because you're the root. You can't forward it to anything, so you can't do any lookups. If you happen to create a root domain in your DNS server and you don't want it to go away, boy, we struggled with that one and finally looked up and it said just delete the dot. Once you delete that zone, you become a DNS server. Top-level domains are the .coms, .edus, .biz, .xxx now, I guess, those servers. And those servers list the second-level domain, and the second-level domains list the subdomains. The second-level domain would be like a ecpi.edu. The .edu would be the top-level domain. The second-level domain would be ecpi, and then if we had something further, maybe we had a Skyline. We had a lot of resources here. Skyline might be a subdomain of that. The DNS domain portion of the namespace to the right of the host name, www.microsoft.com. The namespace is the microsoft.com. Fully qualified domain names takes into consideration the computer name and the domain name, all of that appended together, the entire name for the host, for the namespace. And these things have DNS records created. The A records represent resources, and for IPv6, AAA records represent the resources. Representation of the roots, the top-level domains, second-level domain, Bender Technology, and Bender Technology, BenTech, is the domain that they use throughout this book. They tend to use different ones in different books as we go through these things. And then the subdomain support.bentech.com, and server 01 would be the server that was there. Fully qualified domain name, server01.support.bentech.net. So each of these represents one of those terms that we just had. We'll leave that one there. The who is, I want you to learn how to use the who is. It's a very handy thing. And as well as doing the activity in the book, see what you can find out about ecpi.edu. I think you'd be kind of surprised what's there. They want you to use internic. There are a number of who is locations. I give you another one. I had trouble getting the internic one to come up, and I don't know if it's just because of the connection I was having on my laptop, or if they were down, or if they've given this up. But there are a number of who is sites. Good thing to have when you need to find information about things, particularly if you get something that a spammer perhaps, and you want to find out who is running it. You may be able to find out some information about it as you try to track those things through. Host, the computer on the internet that provides a specific resource. To me, a host could be other things. What if it was a printer? Would a printer provide a specific resource? It'd be like the ability to print to it. The printer would be the resource. It can have an IP address. So I'm not sure here, to me, that host, instead of being a computer, could be something that has an IP address that provides some sort of value or resource. We get used to computers, and we have things other than computers. The host name given to a computer or host. See, I love this. Up here, hosts are computers. Down here, they're computers or hosts. Can be other things. And host basically is anything that can have an IP address. Could be a switch. Switch provides a resource. Could be a printer. Printer provides a resource. Could be a server, computer, something that's out there that can have an IP address, a router. To make connecting to it easier, using the name instead of the IP address. How many IP addresses do you guys know? How many do you know? How many do you remember? If you're going to go to Facebook, do you know the IP address? There are hundreds of IP addresses to get to Facebook. It's one of those things that DNS can do that allows you to, and I don't know exactly if they would use DNS But I'm going to talk about round robin here. What round robin does is puts two IP addresses in for the same name. And you designate it as round robin. And the first request comes in, sends to the first IP address. The second request sends to the second IP address. The third one goes back to the first. The fourth one to the second. If you had more than that, it would just keep going around in round robin fashion, sharing the load across the multiple resources. That's what the big websites do. They actually use locational data so that you go to the closest one that's there. A DNS zone, collection of connected nodes served by an authoritative DNS name server. And we've introduced a new name here, authoritative. Authoritative, in simple terms, means that you can go to that DNS server and change records. Authoritative is the starting point for those. So authoritative server is one that you can go in, you could add an A record, you can modify an A record. Collection of collected nodes, and I love all these terms, collected nodes served by an authoritative DNS server. Something that might mean a little bit more, how about roanoke.ecpivab.edu? The zone is roanoke.ecpivab.edu. The collection of connected nodes are all the computers in the building, all the servers in the building, all the printers, all the devices that are here would be those collected nodes. The authoritative DNS name server would be the one over there in the NOC that actually has a zone that you can go in and modify. The difference between authoritative and non-authoritative, we can't make changes to. DNS records used to provide the information that it stores in the database, and there are a number of records. Active Directory uses SRV records to find the resources. That's what's the big deal is about it. When you sit down and log on to these computers in the morning, the first thing the computer has to find is the primary domain controller, the domain controller that can authenticate you. Check to be sure that who you claim to be based on your username and password. If you can't find a domain controller, you just simply don't get authenticated. And occasionally you've seen in these machines when the NICs go to sleep or the ports go to sleep or the NICs go to sleep and they don't wake up in time, that can't find an authentication server. That means that it can't find a domain controller. Couldn't find a domain controller because the NIC didn't wake up in time and get its IP address for you. Another representation of the root, the top level domain, the second level domains, and then the subdomains, na.bentech.net, and then the EU area in each of these things. DNS zones, and they're talking about delegation. They've got an activity for you to delegate, and what delegation does is we, roanoke.ecpivab.edu, are a subdomain of the ecpivab.edu domain. We're delegated the authority to make changes to those domains. If we didn't have the delegation, we couldn't make changes to. So we maintain the database for our Roanoke domain. Queries, iterative, two types of queries are iterative and recursive queries. An iterative query, the client requests the best answer that his DNS server can provide. Recursive requires an answer. Recursive says just give me the answer, don't go through any of the other stuff. This represents both an iterative and a recursive lookup. The client asks for a recursive answer from its DNS server, which says to the DNS server, just give me the answer. The DNS servers themselves use iterative lookups. If it looks into the DNS server and it doesn't have anything in its cache, then it starts with the root. The root refers it to a top level. The top level refers it to a second level. The second level may refer it someplace else. When you do these things, you have to think about where you're going to get the information from. So Chris, we're trying to resolve RKE, or let's try to resolve something at Virginia Beach, VAB, whatever their servers are. What would be the process for DNS? What would be the process? Right there. You go to your DNS server. The DNS server 10.60.1.4, which is the one that's here. The DNS server over there, and it doesn't have a listing. Let's say it doesn't have a listing. It probably would by now, but let's say it doesn't have a listing. Where's it going to go? To the root server. Where's the root server going to tell it to go? To the EDU top-level domain server, right? Where is it going to tell it to go? In this case, we're probably going to tell it is, oh no. Because there's an ECPI EDU, there's an ECPI net, there's a Skyline net, and they all go to the name servers at Virginia Beach, but I don't think there's an ECPI VAB listed there. Point I'm trying to make here is there are private addresses and public addresses. You may have to educate your DNS server. That's the conditional forward. I'm going to say that a lot because that's kind of a concept that students in the past seem to have had an issue with. So how could we fix that? We go into our DNS server and say, hey, when you try to get to the ECPIVAB.edu domain, don't go here. Go to Virginia Beach, and we put the IP address of the server, the DNS server at Virginia Beach there in order to get that information. And if we needed to get information about a resource at Raleigh or Greensboro or Greenville or any of those places, they wouldn't be in this public area. They'd be in the private area. We have to tell it to stay in the private area in order to resolve. Yeah, you have to have the IP address of that server. But you can get anywhere as long as you, well, as long as it's connected and routable. You're talking about in our domain? Yeah. We can get to Virginia Beach. We don't really, as far as I know, have a routed path to the other campuses. We have the information about them. And that comes in handy. We have that because if somebody from one of those other campuses comes here, they should be able to use their credentials to log on to the network because that information gets replicated down so that if for instance, when we go to Virginia Beach for these meetings, we can go in and pick the Roanoke domain, log on with our Roanoke credentials, and get onto the computers. Doesn't mean you get access to a whole lot of resources, but you can get onto the computers and then use whatever is available there. So you don't have to create names for people in the company as they go from site to site, location to location. But in this case, yeah, as long as you can find the IP address, you can find the resource, presuming that we're fully routed, absolutely. Where would those things be listed? In our private DNS structure, not in the public DNS structure. So we got public structure addresses and private structure addresses. And when you set up your domain, you really need to think those things through. What addresses are you going to use for your public and what addresses are you going to use for your private? And honest to goodness, some of the resources depends on where you are. If you ping virtualpc.skyline.edu here, I'm betting you get 10.60.67.249. If you ping virtualpc.skyline.edu at home, you know that 10 is not going to work. It's going to be a 199 something something something, and I don't remember the addresses. So even whether you use the public address or the private address, you can structure DNS to do that too, because it's going to be probably much quicker to use the LAN connection to go right over here to the NOC than it would be to use the WAN connection to try to get around and back through. Occasionally we have to do that. And the flexibility that's available, we've had on occasions get to Moodle, for instance, from here, which is roanoke.ecpivab.net, right? roanoke.ecpi.net. roanoke.ecpi.net. If the WAN link goes down, then we have to, the WAN link to Virginia Beach, the private link goes down. Then we have to use the public access. You can still get to it publicly using the public address. Causes me some issues because when I restrict it to this local area network only, it doesn't know that you're on this local area network because it gets a natted address and it thinks you're on a 199 something or another. So how you do these things, DNS and the way you construct DNS really can have a major impact on how well your network works, whether you can find things, forwarders. We've had some issues on occasion. When we first set up this network, we kind of had some disagreements on how things should be done. In here, we have some trusts and some DNS. DNS is absolutely critical in trusts because you can get onto the computer called Ranger, which is in an entirely different domain, that has some things on it. It has a trust with the eCPI domain. It trusts your credentials. But in order to find that, we have to configure DNS so that Ranger can find, so that CarGuru, the CarGuru EDX domain, can find the eCPIVAB.edu domain, and the Roanoke.eCPIVAB.edu domain can find it. You have to set those up. Conditional forwarders are a great way to do that. And again, I can keep saying that. I think it's chapter 6 where you actually configure a conditional forwarder. They're a big deal. To me, they're a big deal. DNS clients, sometimes called, often called. They say often called, but when you see the term DNS resolvers, that's a client that does these things. The Windows 2008, the DNS client to perform DNS queries on behalf of the client. The client wants a recursive lookup. Recursive says just give me the answer. Iterative, DNS servers normally don't ask for recursive lookups. They do an iterative lookup to where they go through the process. They go to the root. The root refers them to the top level, to the .edu. The .edu refers them to the eCPI. The eCPI probably going to give you the final answer. And once you get the final answer, then the DNS server gives that answer to the client. At the same time, the DNS server caches that lookup, so it doesn't have to go through that process the next time you ask for that resource. It just simply looks in its cache. The cache records are usually good for a certain amount of time. They will time out like everything else. They have a time to live. And there's a standard time to live, and you can change the time to live with those things. DNS queries needs to know which server to contact. The first DNS server in the list is called a preferred DNS server. You can have more than one. And what that means is if the first one isn't working, the second one will try to do that. So it goes down the list to try to resolve these things. That's why in the lab they're going to have you put in some forwarders. Forwarder says DNS server, send it to somebody else to ask the question. If you want to keep your DNS servers off of the internet, the way to do that, send the information to a forwarder, just like the conditional forwarder we talked about. The difference between a forwarder and a conditional forwarder, a forwarder sends everything. Conditional forwarder only sends the information for a specified domain to some other server to find the answer to the question. These, I said 4.4. 4.2.2.1, 4.2.2.2 are a couple of available open DNS servers on the internet. And what they've done here, they, in this book, use 192.168.100.10 for everything. Well, that ain't going to work. You need to use your own assigned addresses for what we're doing, what you're doing on these things. So you're going to add an alternate. None of these labs, you notice these are really time-consuming labs. 10 minutes, 10 minutes, 10 minutes, 10 minutes. There are a lot of them, but 10 minutes, 10 minutes, 10 minutes, 10 minutes. They really don't take all that long to do. Dynamic updates is something that is available. It's available to you too. If you look in your router, you can probably get a free dynamic update so that you can use your DNS address, your IP address, and it gets listed in a free dynamic DNS server, which means that if your cable company changed your address, and we talked about DHCP, they tend not to do that. They tend to be persistent because of the 50% renewal time. You can list these things. Where it really comes in handy is in Active Directory, because we have, what, 150, 160 computers in here? Not a very big network. But what if you had to put 150 or 160 addresses in every day? Dynamic DNS means that the computers themselves register with the DNS server, and they should unregister with the DNS server when they give that address up. There are some configurations, and a lot of DNS, most of this DNS configuration is actually in DHCP, not in DNS. The service is available, and it's not anything that is unique to Windows. Linux has dynamic DNS, so it's not like, okay, yeah, this is bind 8.1 or something like that. If you have that particular version of DNS on up, the Merkley Internet Domain, the de facto, everybody uses that. Dynamic updates, sometimes referred to as DDNS, DDNS, dynamic DNS. Computers register themselves as the IP address changes. They report that to the DNS server. The old records should come out. They don't always come out correctly. That's why we have scavenging. Scavenging looks for old records and deletes those records. Often combined with other services such as DHCP and the dynamic DNS who reports that information to DNS is a DHCP configuration. If you have older clients, really older clients, we're talking NT4, Windows 98, Windows 95, if anybody still has those, you can tell the DHCP server to report those assignments to DNS so that you get a dynamic update. Issue here becomes, if the computer reports it, then the record belongs to the computer. If DHCP reports it, the record belongs to the DHCP server. The only thing that happens there is sometimes it's hard to get the records out of DNS if you need to make them go away based on the ownership of the records. Caching only means that we don't have any zones. Caching only just means that it goes to the internet, finds the IP address for Yahoo and Google and Facebook and all those things, and records it in its DNS cache, so that the next time you don't have to go through go to the root, go to the top level, go to the secondary, go to the subdomain if necessary. Means that we don't have and in this case they're going to use bentech.local, we don't have a bentech.local listing. We don't have a roanoke.ecpivab.edu listing of all the computers that are here. We're not going to be authoritative for any zone. Authoritative, we list the zone, we can put records in, we can take records out. It's going to just get the information and store the cached information. And when you install a DNS server, just as a regular DNS server, that's what it is a caching server, because it doesn't have anything. And then what they're going to have you do does not maintain any DNS records. What they're going to have you do as you go through the lab is create a zone and put some records in that zone. So install it. Root hints provide the IP address pointers for the top level domains. The 13, that you have heard that before, right? The 13 servers, if you can take them down, you can take down the internet. Do you believe that?
No.
Why don't you believe that? I do. I do, but where are those 13 servers?
Well, aren't they like spread across?
They're spread across, and it's not like they're just 13 servers out there. There are hundreds of them. And yes, if I could take down all the DNS servers, could I take down the internet? Probably. I say probably, but what about the information that you have cached on your DNS server? It's going to be there. You're still going to be able to use those lookups. Eventually, those records will time out. But if you could take down those servers, you could really do some damage. And there have been attempts at that before that they've tried to. They actually had one that was fairly successful. I think it was last February. It slowed the internet down. Didn't take it down, but it slowed things down a little bit. So the root hints are the IP addresses for the root servers. Excuse me, not the root servers, the top level domain servers. The root obviously is at the top. The top level domain is where we're going to go. So when we say we do all those things, we don't really do all those things. The hints are right there in your own DNS server. Knows where to go for the top level. Provides the referral answer to the DNS queries. If I want an edu address, I go to the edu server. If I want a biz, I go to the biz. If I want a com, I go to the com server. Forwarders, servers used to resolve names, and I've talked about forwarders and I've talked about conditional forwarders, two different things. A forwarder itself just simply forwards the information to another server. The CD that we use for the Server 2003 class had a problem with the root hints. And I tried putting new files in, and I think about the time we transitioned to 2008, I actually finally got it fixed. But it wouldn't resolve anything on the internet. Actually, it would resolve .net, and that was it. The way around that was to create a forwarder on all of those servers that forwarded the lookups for the internet to something else, to the 1061.4, 1060, 66, 253, something that could actually resolve that. So if it couldn't do it, actually not if it couldn't do it, what it would do was anything it wasn't listed on its machine, in its zones, it would send to the other server to do the lookups for it. If you want to maintain isolation of your DNS servers, of your Active Directory DNS servers, for instance, you don't want them going out to the internet, you can use forwarders. You could set up a caching server. The Active Directory server would then forward its request to the caching server. The caching server will get the information and then send it back. So you can use those things. Zones are the building blocks creating the infrastructure, classified in three ways: the information they store, where they're stored, the read-write status. The information that they store, where they are stored, and where they're stored is either going to be in Active Directory integrated, or in the text file, the DNS zone file, which is going to be on the hard drive. The read-write status, whether you can make changes to it or whether they're a read-only, a primary or a secondary zone. Two categories, standard and Active Directory, are going to be those. A standard zone, Active Directory. Active Directory integrated zone simply means that the information stored in Active Directory replicated through Active Directory. And Active Directory uses DNS in order to make that information easy to find. Where is the domain controller? Where's the global catalog server? Where are you going to use for authentication? Those things are all listed in there. The standard zones are listed in the zone.dns file, and it is a text file that is in the system root system32 DNS folder. It's going to be there. For those of you who have had the Linux class, he made you write those.
Yep,
right?
Huh?
Wasn't that fun?
Yeah.
He made you write those. What is it? So you know what it looks like. It's just a text file. And we're not going to write them here. What we're doing here is learning how to hopefully integrate DNS so that Active Directory works and it works for the lookups alike. And we keep some isolation between our Active Directory information and everything else. Berkeley Internet Name Domain, the bind is the standard that everybody uses for DNS. Linux uses it, Windows uses it, everybody uses it. Berkeley, and this is Berkeley University, is where this came from. So it's something that's out there that Microsoft can't claim that they own, that, of course, Linux doesn't claim that they own anything, but Linux can't nobody can make a claim to it. Primary zones, the zone is authoritative. And what does authoritative mean? In simple terms, authoritative means that we can go in and make changes to it. Authoritative, the zone that is authoritative for a specific domain is domain records, which means it's a read-write. It is a writable zone. Secondary DNS zone is a read-only. We're going to use this thing called a zone transfer. And oh, by the way, by default, the zones don't allow zone transfers. You have to configure to allow a zone transfer. And when you do the NS Lookup Lab, they're going to ask you to do the transfer, and I really didn't see it, may be hidden well, where you actually turned on zone transfers. If you don't do that, you're not going to dump the records. And then the last one there was a stub zone, and the stub zone just simply lists, it's a read-only copy of the zone that contains its resource records from the name servers that are authoritative for a particular zone. What this says is the only thing it's got in there, it's actually got the start of authority record and name server records, which refer you to the location of the authoritative servers. They're going to have you install another 10-minute or, oh, we're up to a 15-minute one on this one. Secondary zones. A forward lookup zone allows DNS to resolve FQD into an IP address. We've got a forward lookup zone and a reverse lookup zone. The reverse lookup zone maps the IP address to host names. A lot of people don't use those, and I don't think we use those in ours. They can be handy at times if you know the IP address that something's going on with and you need to immediately get it back to a name. You can do that anyway. If you go into your DNS server, you're going to have a name to IP correlation, obviously. You can always find that address, but reverse lookup zone maps the IP address to the host name. And they will work together. When you create the one, you create the other records, point A records and pointer records. Information in the DNS record, owner, the time to live, the class type, resolution, resource data, time to live, one of those things that might be important. When you put the record out there, how long is it going to be good for? When's it going to go out of the cached servers? They don't cache for everything, forever. Start of authority, starting point for the information related to a zone. This is where the start of the authority for that particular zone. Each of these records, and they're going to have you look at them and do some configuration with them, have some information in them that can be changed. An NS record, a name server record, is how you get to the computer that lists all of the A records. The name server record for ecpi.edu is something with an IP address, because when we go to the root, go through our whole process, and we go to the edu top level domain, it's going to refer us to an IP address that has the ecpi.net, ecpi, whatever records that are public. It's going to refer us to a domain or a name server, a computer that has that information. The NS record is that name and IP relationship. To find information for this domain, go to this record. And when you do the delegation of authority, they're going to have you create one of those. Because when they delegate from Virginia Beach, says, hey, Roanoke, you maintain your own records. The only thing they list in the ecpivab.edu under the Roanoke domain is a name server. So there's somebody from Raleigh needs to get that information. It goes there. It says, hey, I don't have it, but I know the server that does. Go to this IP address to get that information. Resource records, and you probably, all you had in the Linux class have already been through all of these. The host records, the triple or the quad A, the 4A records are IPv6 A records. So you got an A and an AAA. A is IPv4, AAA is IPv6. MX records represent SMTP servers, mail servers, mail exchanger records. Alias records create an alias for a specific host. I think one of the things that those are handy for, if you have an address, if you want to use the same name or different names for the same address, you can use an alias record. Or if you've got a name that people misspell a lot, you can put the misspelling in there and it'll automatically refer it to the correct record. Pointer records, IP address to host names. Pointer records are going to be in the reverse lookup zones. Service locator, and these are the ones that are important for Active Directory. Service records or service locator records, SRV records. Where is the domain controller? What's the IP address? Where is the license server? That's a big deal for us. Automatically license our machines. The machines, when they join the domain, have to be able to find the location of that licensing server. And in this domain, they in fact can do that once they join the domain. And then when they need to renew, they've got or revalidate, they've got to be able to find that particular server. If you had a time server that you were running, you could put a resource record for your own time server in there, and that or whatever you want to, whatever you need to use in the resource records. And typically, whenever you install something, it's going to install its own record. The licensing server put its own record in, for instance. DNS zone transfer is the master server, and you can count on you're going to have to do a zone transfer at some point in time, and they're going to have you set up to do a zone transfer. What a zone transfer does is simply takes the information from an authoritative server and stores it in a secondary zone so that you have that information available locally, for lack of a better word. By default, Windows servers don't allow a zone transfer. You have to configure them to allow that to happen. I've got Ranger set up to where it automatically does that. It allows transfers to everything. It's because you can't get off campus with it. It's set up to do a number of things within the classes to demonstrate these things. But if we, for instance, wanted to list the records for all of the computers, all of the information at Virginia Beach, the ecpivab.edu domain, we could do a zone transfer and get that information here. Once you do the zone transfer, you still have to update those things, replicate those things. I've always personally thought that conditional forwarders probably the easiest thing because you don't have any replication to worry about. And they always say, oh, well, if you need them listed there, in case the WAN link goes down, then you need to have a secondary zone. And if the WAN link goes down and the conditional forwarder doesn't work, what's the difference? Because the WAN link's down, you can't get there anyway, conditional forwarder or secondary zone. It's just a matter of which way you want to configure it. It could be with a secondary zone opinion with a secondary zone, or it could be with a conditional forward. You could do either. Zone transfers, incremental IXFRs are incremental zone transfers, full transfers, AXFRs. By default, these machines do incremental zone transfers, which means that they only replicate things that are changed. They don't do full transfers except when they start up. You can do a full transfer, or you can do a manual. You can force a full transfer if you want to do that. SOA query, the response, and then the IXFR, AXFR query, what are we going to do? The secondary zone actually checks, and there's a serial number, compares its serial number with the serial number, the update number of the master zone, and if it's changed, if they're not up to date, then we'll do a comparison to see what's changed and send the records that have changed. And again, initially, obviously, you have to do a full zone transfer, but you don't have to do those frequently. So, wandering around DNS is a really big deal. DNS really big deal making the internet work. DNS really big deal for making Active Directory work. And until you've messed it up with Active Directory a couple of times, you don't understand how big a mess it can be if DNS isn't working correctly. When I try to figure out, and this is just me, and this is probably kind of silly, what DNS, why isn't working, just like when routers aren't working, imagine where the packet's going. This is where it says to get the DNS information. Well, just like the example I gave, if you're trying to resolve an ecpivab resource, you know it's a private resource, it goes to this DNS server. How's that DNS server configured? If it doesn't have a forwarder of some sort to get that information from the private DNS listing and it goes out on the public network, you're never going to get the answer. If you want to create your own shortcuts or whatever else, you can manage the host file. The host file you actually I'm going to put an entry in it in the next chapter, in Chapter 6. Gets a little bit more involved. Core functionality, name to IP address lookup. The zones are primary, secondaries, and stub zones. The primary is one that lists the records. The primary actually becomes, in most cases, authoritative. And I've seen things that primary doesn't necessarily mean authoritative, but how can you be primary without being authoritative? Because primary is the one that lists the records that you have, that you can make changes to, and that's what authoritative means, that you can make the changes. That's the starting point for that zone. Secondary zones, zone transfers are read-only copy of the information. Stub zone simply has the start of authority records and name server records, that it refers you to an authoritative or someplace that you can actually get the information. The records, we have the A, the 4A, the MX, the pointer, and the CNAME records are all available in Active Directory. The DNS console is the GUI tool that lets you add and delete records, modify the records. You can also use the DNS CMD command in the core machine or at the command line. Once you get enamored of the command line, once you learn the commands, some of that stuff really is quicker to do at the command line than it is through the GUIs. Questions? I do want to show you, okay, we'll open the DNS server. What do you not see here? If you can see that far. I've got forward lookup zones, reverse lookup zones, and conditional forwarders. And conditional forwarders, again, they've made it a lot more obvious where you configure those. But you don't see the cached zones, do you? So don't see any cache. You can delete the cache. We should be able to go in here in View and turn on Advanced, and now we get our cached lookups. So if you want to see those, they don't show up by default. Just like in Active Directory, a lot of stuff doesn't show up by default. You've got to go into the View and configure to show you the Advanced. If you want to see those things, see where people are going, what they're using, the cache, or if you want to make the cache go away, if I then want to delete the cache, I can clear the cache, start over. Got bad records, something's going on that I don't really want the cache anymore. You can delete it there. You can refresh it. You have the all tasks. But in order to see it, you've got to go into View and turn on the advanced view of this thing. With that, are you ready for a break? I'll quit now.